in your notebook. Combining functions algebraically, so we're going to be using highlighting as a strategy. Huh? We're only using 2.
Oh, I don't like blue, so blue's out.
Okay. So, before we get to the modeling of the actual skill, we need to know a couple things going into it. So I'm going to use our highlighters, or one of them at least.
What color do you have?
I have yellow and pink.
Alright, fresh.
Okay. So I'm going to start off highlighting a couple of key pieces of information. So at the top it says, when adding or subtracting, just combine like terms. You actually already know how to add functions together because all it is combining like terms.
Should we take this in here?
You can tape it in, yeah, that's fine. All right. Cool. So I'm going to highlight combine like terms.
What color?
Any color. So when adding or subtracting, combine like terms. The second bullet says when subtracting. Does it say addition?
No.
No. So only with subtracting. So I'm also going to highlight subtracting. Apply the distributive property. I'm going to highlight distributive property to the second expression. Does it say to both expressions?
No.
No, just the second expression. So I'm going to highlight that as well. So again, when subtracting, apply the distributive property to just the second expression. All right. Now we're going to take a look down at our addition section first. Okay. So it says under addition, f of x plus g of x is the same thing as f plus g of x. This is just a new function notation, but it still just means that you're going to put those two functions that are different together to make just one function. That's all it's saying. All right? So in order to clearly do that, I'm going to highlight each of these functions in a different color. So I'm going to do f of x in one, and g of x in my second color. It might also help you to highlight what's above it. So again, g of x gets written after that. And f of x is the first function to get written. And I'm actually going to continue using my yellow highlighter. And I'm going to create a space where I'm going to write down the actual equation of f of x. So I'm going to highlight it yellow right there. There's nothing there for me. It's fine. It's still going. Yeah. Screen is just idle. It's still recording. All right. So where I highlighted yellow, I'm going to write the equation that represents the function f. So I'm going to write 5x plus 4.
How am I supposed to write it? Because this is really dark.
You could use a pen, so that's darker.
Ooh, this is really dark.
You can problem solve and swap with another student.
Anyone else want to switch?
Or you could share.
Alright, sorry, Jeremy.
Oh, look at Jeremy. He's been so nice.
Thanks, Jeremy. You said that.
Okay.
Yeah.
Now I'm going to create a spot to write g of x. And I'm going to write it next to it.
Should I use this one?
You can still use orange. You guys can share. You're adults.
We are?
Sharing.
Working towards it. Okay. Alright. So what am I going to write in the pink spot?
The 4 minus x.
Good. 4 minus x, because that's the equation that represents function g. Now, again, which operation are we using in this specific question?
Addition.
Addition. So I'm going to put a big old addition sign in between it. Now, this is the easy part. We're going to combine like terms. Let's refresh our memories. What are the two things that have to be the same to combine terms that are alike?
X.
Jeremy.
The variable.
The variable.
Which is x.
Sometimes x, sometimes y, sometimes n, sometimes b, etc.
Any other.
What is the second thing that needs to be the same?
The non-variable.
The sign.
Not the sign.
The
The
number.
numbers.
No, they're not.
Which number?
The one with
X.
the variable.
The one from the variable.
This one actually is not present in this problem.
The one with an exponent.
What?
Exponent.
Exponent. So the variable and the exponent have to be the same in order to combine them together. Okay? So, can someone list for me a pair of terms here that can get combined? Asa?
4 and 1.
4 and 4. I'm going to put circles around them. What's 4 plus 4?
8.
8. I'm going to write this towards the back because, again, any term written with a variable has to get written first. Sue, what is the other set of terms that can get combined?
5x and x.
Good. I'm going to put a box around those.
I think
So
I
what's-
remember doing this last year.
Well, you also did the beginning of this year, so hopefully you do remember it. So what's 5 minus 1?
I remember this.
4.
4. So we have 4x. That is your final answer. 4x plus 8. Okay? So now what I would like us to do, though, we're going to practice addition again. But we're going to practice without the highlighters because sometimes you don't have highlighters with yours. Maybe you're not a color coding kind of person.
Plus 8.
Which is okay. 4x plus 8. Yep. So we're going to go down now. And we're going to be using these two functions. F of x equals 2x squared plus 1. And g of x equals 3x squared plus 9. We are doing f plus g of x at the bottom. What do I do first? Asa.
Like copy them down.
Copy them down. Great. Which one do I write first?
F of x.
Good. So I have 2x squared plus 1 plus, because this is my big addition sign, what do I write next? Someone new. You're not new, Asa.
I'm confused.
So, Jeremy, I need to combine the functions f, given right here, and the functions g, given right here, together to make one function.
Plus, okay, I get it.
So, what am I adding to f next, Jeremy?
3x squared plus 9.
Now I combine like terms. Henry, can you give me my first pair of terms that can be combined?
2x squared and 3x squared.
Beautiful.
I know. Oh, so we don't actually know what's like x.
You do not know what x is equal to, no. Again, you're going to end up with another equation, not a final numerical answer.
So mine's pretty much the same thing, but it's like opposite.
Yeah.
Not really.
A little bit different because we have one more added step in there, but yes. All right. So 2 plus 3 equals how many x squareds?
2.
3,000.
5x squared. Nice try, Jeremy.
Plus 10.
And I was
Okay.
guessing there.
And the last pair of terms that can get combined together, Asa?
1 and 9.
It equals 10, but it's 1 and 9. Yep, so I'm going to circle those. So I'm going to write plus 10 there. That's your final answer.
Got it correct. Woo!
All right. So we've done addition.
Now,
Now we're going to do subtraction. Again, the top one we're going to use with highlighters as a visual, and then the bottom one we'll do without. So now I'm back up at the top. I'm going to, in the same manner, color code my function. So f of x is one color. And I'm actually going to color, again, the above part, just so we pay attention to the order.
But we weren't. Can I just leave the other one as blank? So I know which one's which.
Yep, that's fine. And then I'm going to highlight g of x. So which function gets written first? F of x. So I'm going to highlight an area for it to go in. And that function is,
5x plus 4.
what operation am I using again, Asa?
Minus.
Yep, subtraction. So I'm going to write a subtraction sign in.
Minus.
Before I write in g of x, if we look back up to what we highlighted, it says, when subtracting subtracting, apply the distributive property to the second expression. If I'm going to apply the distributive property to the second expression, what needs to be around that expression? Parentheses. So I'm going to put parentheses first, and I'm going to highlight inside. I'm going to write.
We should shouldn't we like
No, I
highlight
wanted
after?
Sometimes though with my black ink that I'm writing with, it smudges.
Yeah, but then if I write when the thing is highlighted, it rips the paper.
What?
Oh, sorry.
So you want to rip the
It's
paper.
It's a
okay.
lose-lose situation, Henry.
Lose and
It's
lose.
usually fun.
Okay.
Oh.
I just want a
Boys.
win-win situation.
Alright. So now, again, I need to apply the distributive property.
Oh, I
What
know.
am I distributing?
Negative.
The negative sign. So how does this negative sign change for someone other than AC? I love how much you're
It
participating.
makes sense. Negative.
-4 and then
Good. -4 and?
Negative x.
Ah,
No,
positive.
because two
X
negatives
is
make them
already
positive.
negative, okay?
Oh,
So
so
Correct. So plus x. Let me ask you this. Does the first part of the expression written in yellow, does that change?
No,
No.
because it's not in parentheses.
Not yet, because it's not in parentheses. So I'm going to recopy that down. 5x plus 4.
Equals 6x.
The great thing about this particular problem is if you look at these numbers,
You
is there
can
any
group
way?
them.
What?
You can group them from +4, -4,
There you
and
go.
then
So what happens when we have opposites, though? Asa?
Oh, you can minus them out and it makes 0.
Make 0. So they get canceled out. I'm going to cross them out right now. I don't even need to spend time on that.
With 6x.
So the only thing I need to combine is 5x plus 1x, and I get 6x.
Success.
Indeed.
I like that.
Okay.
I'm stealing it. It's mine now. Trademark.
Okay.
I
I think we are ready to go down to the bottom one. We are no longer highlighting.
No highlighters for me.
Alright? So please, again, take note. Order is very crucial here. F always, well, not always, but F is written first in this spot, so F has to get written first down here when we copy it down. Okay?
What we did last
So what is the function F that we're writing down?
3x squared plus
No.
Nope.
2x squared plus 1.
2x squared plus 1.
Damn, flipped the wrong way.
What operation are we using?
Subtraction.
Subtraction. What else do I need before I write my second expression?
Big fat negative.
I got that.
No, the
Parentheses.
parentheses. Huh, I got it first.
Oh my god.
What goes inside?
The 3x squared plus 9.
Oh, you guys are like best friends.
What?
Alright.
So,
Who is up for a challenge?
I am.
Okay. I want you to finish this problem.
I want to finish that.
So,
I'm going to do it, but I'm going to hide the answer from you.
Okay. So, ooh, that's tricky.
wait, when do club or after school activities start?
Monday.
Winter?
Next Monday?
Yesterday, Monday.
Oops.
Why?
I didn't think I missed. I had homework makeup yesterday.
Do you want to put that on?
Oh, so if you have homework makeup, though, yeah, that's kind of a given that you're not going to.
But today, I'm gonna go.
where you at? Where you going to?
I'm not 100% sure. So, I'm just gonna go see Mr. Fossey, right? Who's in charge of the after school?
Fossey.
Mr. Fossey?
Yeah, I'm gonna ask him what I have. Unless you can
Lisa?
find
No.
Alright, well, I'm done.
I'm not.
too.
I had trouble doing it.
Can
It's okay.
Can I guess?
roasty.
Yeah, like, check the answer, make sure mine's right.
In a moment when I post it.
I don't think I'm gonna get it right,
It's
but you know, that's just how it's gonna go.
Squared minus 8.
Sue, do you have your old challenge problem with you?
I think so. I think it should have.
I don't.
I found my old one.
The football player one?
I got it wrong.
The
Let's go.
Cube one? Yeah, the cube.
Alright,
oh,
ready?
You weren't here. Were you here today?
The cube one.
Oh yeah, that if there's a cube, it
Let's
would make
see.
sense.
Did I get it wrong?
Alright, Henry and Asa. Shh. You guys ready?
Yes.
I think I got it wrong.
Here's the answer.
I got it wrong.
Got it right.
Oh, shit.
My
Oh.
favorite.
Wait.
Copy
What
that.
happened?
Boom.
Oh, it's not -2. I mean +2. It's
2 minus 3, which is -1.
No, it's the -8. I said -7. Look at the rest right. Cause I thought it was +2, not. Oh shit.
Can you explain the
Oh god, this is
challenge
so
problem?
bad.
I
Yeah.
really don't understand it at all.
So
What?
annoying.
Alright, so this concludes today's notes.
Woo! I'm gonna put it in.
Loud clap.
Alright, I am going to
What is this tape?
give you guys a head start on your homework.
Oh, homework.
I'm going to give it to you.
Me
It's
too.
on this, though. Okay?
On that.
This is what you're doing for homework.
Oh, well, it's already done.
Well, not this page, but this concept.
Okay.
Alright, so I'm going to collect the tape.
Here's my tape. I'll pack my. I need to put
My
my
own